Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA Physics Paper 1 Higher Tier from 2025. Question number 10 is on the topic of energy. Figure 12 shows a device that accelerates a toy car at the start of a racetrack. So we have a spring. In front of it is a toy car with a handle, and with the handle is being pulled. Okay. Pulling the handle compresses the spring. Okay, so the handle is actually going through the spring. It's not actually pulling the spring. Okay. Pulling the handle compresses the spring in the device by 0.075 meters. When the handle is released, the energy stored in the compressed spring is transferred to the toy car. Spring constant equals 64 Newton per meter. Mass of the car is 0.052 kilograms. Calculate the maximum possible speed of the toy car just after the car starts to move. Use the physics equation sheet. It's a 6-mark question, so obviously there's 2 equations that we'll have to use and give you an answer in 2 significant figures. So maximum possible speed, that's going to be with a velocity, and for that I would need to know the kinetic energy. If I can find the elastic potential energy, then law of conservation of energy says all of the potential energy, elastic potential energy, is converted to kinetic energy. That will be the maximum speed. So elastic potential energy, E equals half KE squared. So 0.5 multiplied by the spring constant, which is 64, multiplied by the extension here, it's compression, so 0.075, 0.075, but that needs to be squared. That gives us 0.18 joules. Now, elastic potential energy, E is equal to the kinetic energy. Now, KE is equal to half mv squared. So 0.18 is equal to 0.5 multiplied by the mass was 0.052 multiplied by velocity squared. V is equal to the square root of 0.18 divided by 0.5 times 0.052. That gives us 2.631. In 2 significant figures, it will be 2.6. Now, there's alternative ways of actually doing this as well. You can use the equation F equals KE and find the force. Or actually, yeah, you can find the force, and then using F equals ma, you can find the acceleration, and then you can use v squared minus u squared equals 2as in order to find v. That's in the 3-step process, which is a bit longer. Figure 13 shows the path of the toy car along a loop section of the racetrack. So for the racetrack with the toy car and the loop, the car moves along the track from position A to position B and then position C. Describe how the energy stores of the car changes as the car moves along the track. from position A to position C. So at the start, the car has kinetic energy, does not have GPE. Here it has GPE, does not have kinetic energy. Right at this point, and then it's starting to fall. So the GP is then being converted. So right at this spot, all of it is GPE. There's no KE, and then it's actually falling. Here it will have kinetic energy, no GPE. Right. A to B. Kinetic energy decreases, but gravitational potential energy increases. B to C, gravitational potential energy decreases, and let us KE, kinetic energy increases. At the end of the racetrack, the toy car passes through the light gate that measures the speed of the car. Which two measurements are needed to determine the speed of the car? The length of the toy car, not the mass, not the temperature, time for the car to pass the light gate. That would give you the speed. That brings us to the end of this video and to the end of this test paper as well. Thanks for watching. Hopefully you find this useful. And if you do find it useful, consider subscribing to the channel for past paper questions on both biology, chemistry as well. Thanks for watching. This is Ketish again. Bye for now.